Hello, Namaskar to the all doctors and engineers of the near future and all the chemistry lovers. मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं केमिस्ट्री वाला चैनल पर. In previous video we have discussed about the just organometallic compounds. Today we'll go with the very important topic regarding to just for each and every student of the class 12th and NEET and IIT also. It will be one of the question from this topic. So this is the metal carbonyl. It's a constitution of two words, metal and carbonyl. We can say just you can say complex compound just in which metal atom is is directly attached to carbonyl group. Those are known as metal carbonyl. Suppose this is the M metal, this is the carbonyl group CO as a carbon monoxide, carbonyl as a ligand and carbon monoxide as a molecule. If we'll go with the further, then these are also known as organometallic compounds. Why these are known as organometallic compounds? Because of if we'll go with the structure, then metal atom will directly attach to the carbon atom like this. This is the carbon and this is the metal atom. If we'll go with the just regarding to the type of the structure or type of the complex compound, these are homoleptic complex compound. Homoleptic complex compound के नाम से भी जाने जाते हैं because these exist only one kind of the ligand. Oxidation state of metal atom in these complex will be 0. If we'll go with the example, then as an example we can take NiCO's whole 4, FeCO's whole 5, CrCO's whole 6. This is Mn2, just your CO whole 10, and another we can take Mn3, CO's whole 12 also. This was regarding to your just you can say metal carbonyl or as a organometallic compound. Now the time to discuss about the just some other thing regarding to organometallic compounds. If we'll go with the structure of some organometallic compounds, this is the tetrahedral of NiCO's whole 4. This is NiCO's whole 4. If you go with the FeCO's whole 5, then it will be your trigonal bipyramidal like this, trigonal bipyramidal with the you can say sp3 hybridization with the dsp3 hybridization with the just Cr. This is the CO whole 6 as a, you can say, D2sp3. We can take the further example as a Mn. This is your CO. This is your CO. This is the CO. This is another Mn. CO. CO. And this is the CO. You can take over here CO, and this is the CO also. This is the right formula for the Mn2 CO 1, 2, 3, 4, 5, 6, 7, 8. You can take CO's whole 8 means octacarbonyl dimanganese. This is the octacarbonyl dimanganese. Oxidation state is your 0. This is your, you can say, hexacarbonyl chromium 0. This is the pentacarbonyl iron 0. You can see oxidation state is 0. This is tetracarbonyl nickel 0. So this was about the initial part of the just you can say metal carbonyl. Now I would like to go with the types of metal carbonyl. It's very important and romantic topic regarding to coordination chemistry. There are two types of the just you can say metal carbonyl. Types of metal carbonyl. There are two types of the metal carbonyl. Two types. Number one, just mononuclear metal carbonyls, and number two is your polynuclear metal carbonyls. If you will go with the mononuclear, then these exist only having only one metal atom as center or nucleus, and if you will go with the polynuclear, then these having more than one as more than one metal atom as center. If we'll go with the just example of the mononuclear and polynuclear, so as a mononuclear, this is the mononuclear. As a mononuclear, we can take the example of NiCO's whole 4 having only one central metal atom, FeCO's whole 5, FeCO's whole 5, CrCO's whole 6, and as a polynuclear, multinuclear, as a polynuclear, we can take the example of Mn, just 2 CO's whole 8, Mn2 CO's whole 10, This is your Mn3 COs whole 12. This is called as octacarbonyl manganese 0. This is the octacarbonyl dimanganese 0. This is decacarbonyl dimanganese 0. This is the dodecacarbonyl. For 12 it will use of dodecacarbonyl trimanganese. This is the 0. So this was about the just type of the your metal carbonyls. Now the time to discuss about the properties of metal carbonyls. It is very important topic. What are the properties of the metal carbonyl? Then these are as follows. Properties of metal carbonyls. Properties of metal carbonyls. Properties of metal carbonyls. If you will go with the properties of the metal carbonyls, then first is your as the following करके following. First is your you can say oxidation state in metal carbonyl. Oxidation state of the metal carbonyl will be 0. These are homoleptic complex. Homoleptic complex. Next, number third is your only metal carbonyl of nickel, metal carbonyl of Ni and Fe exists in liquid state. Rest all will be in solid state. केवल और केवल निकल और आयरन के कार्बोनाइल कंपाउंड अपने आप में लिक्विड स्टेट में होंगे, बाकी सब सॉलिड होंगे. थर्ड प्रॉपर्टी मोनोन्यूक्लियर जस्ट मेटल carbonyls are toxic in nature, but if you will go with the polynuclear metal carbonyls, then they are non-toxic in nature. These are the properties of the metal carbonyls. First is your oxidation state will be 0. These are known as homoleptic complex because all the type of ligand is same, homoleptic complex, and we can say only complex of Fe and Ni will be in liquid state and rest all will be in solid state, rest all. And mononuclear metal carbonyls are you can say toxic in nature, and if you will go with the polynuclear metal carbonyls, they will as a non-toxic in nature. Now the time to discuss about the bonding in metal carbonyl. Bonding in metal carbonyl के regarding particular discuss करें, then it will be too easier, but it is very important. So this is the bonding in metal carbonyl. bonding in metal carbonyls. Metal carbonyls. For this, we'll take the example of NiCOs, all four. It is also called as tetracarbonyl, tetracarbonyl, nickel 0. If you go with this compound, then oxidation state is your 0. Here is the 0, that's why Ni changes in Ni excited state because of CO is a strong ligand. This is the strong ligand. So Ni is your 28. This is your organ 3D8. This is your 4S2 and this is your 4P0. This is Ni28. This is the 3D as a 5 orbitals. We have discussed as a dxy, dyz, dxz, dx square minus y square and dz square. It will be one of the s orbital as a 4s and 3 of p orbital as a, you can say, px, py and pz. This is the 4p part. Here is the 8 electron, 1, 2, 3, 4, 5, 6, 7 and 8 electron. Here will be 2 electron. In the excited state, what will be? It will be a rearrangement because CO is a strong ligand. So it will over here and these 2 electrons will be over here. So 3D will be as a 10, 1, 2, 3, 4, 5, 2 to 4 to 6 and to 8 and to 10. As I told you, 3D will be as a 3D10, 4S is vacant and 4P is your also vacant, 4P and 4S. According to coordination number, there are required 4 vacant orbital. So hybridization will be sp3 hybridization. Now I would like to go with the complex formation. This is the NiCOs whole 4. So this is your 3D as a 5. This is your 4S and this is the 4P. 4P and this is the 4S. This is the 3D. 10 electron in 3D and this is the one of the lone pair, 2 lone pair, 3 lone pair, 4 lone pair as a CO, CO, CO and CO. So I want to say one thing is common. Here the bonding is taking place, that is your M, this is the metal atom as a nickel, this is the CO and it donates the lone pair of electron to the central metal atom. So this is the sigma bond. This is the sigma bond regarding to as a coordinate bond. If we'll go with the just metal, then this is the metal atom. Here is the vacant orbital, like this you can say. This is the metal atom and metal atom. This is the one of the orbital, 2, 3, 4 and 5. This is the carbon monoxide with the just CO, 1, 2, 3. This is donate the lone pair of electron over here, this type. That's why it is your sigma bond. But if you go with the just further, then what is that? Just you can say their anti-bonding orbital of the carbon and non-bonding of the metal atom, non-bonding, and these are the anti-bonding orbitals. These are the orbitals. What are the just non-bonding orbitals? These are the non-bonding which are not taking part in the bond formation. And anti-bonding of the carbon, they forms a side-to-side overlapping. By the side-to-side overlapping, they forms a bond similar with the just pi bond. So what we can say that metal carbonyl exists the property of metal carbonyl exists metal carbonyl exists property of both sigma and pi bond. And one thing is also, what is that, यहाँ पर्टिकुलर मेटल एटम कार्बोनाइल ग्रुप के साथ में बॉन्डिंग बना रहा है, इसकी डायरेक्शन पहले की कंपेयर में यहाँ तो फॉरवर्ड डायरेक्शन में है, ये बैकवर्ड डायरेक्शन में है. दैट्स व्हाई दिस काइंड ऑफ द बॉन्डिंग इज ऑल्सो कॉल्ड एज बैक बॉन्डिंग. बैक बॉन्डिंग भी कहेंगे इसको. एंड बैक बॉन्डिंग इज ऑल्सो कॉल्ड एज synergetic bonding. So this was about the bonding in metal carbonyl. So we will meet in the next video. तब तक के लिए शुक्रिया, धन्यवाद मुझे सुनने के लिए, अपना प्यार देने के लिए. अगेन धन्यवाद, शुक्रिया.